Hello students and welcome to this series of lectures on project management. Today we will be doing a numerical on project crashing. Your faculty is Dr. Suchitra Srivastava, Professor in the Department of Management in the SAGE group of institutions. Now we have done what is project crashing in an earlier lecture. So what is it? It is basically the reduction in the project duration or the project completion time with the deployment of additional resources. Now please note down the question carefully. The question is, for a given project comprising of 8 activities, find the additional cost incurred to reduce the project completion time by 2 days. So please note, we are given 8 activities today, that is from A to H. The immediate predecessors are given, the time is given, that is the normal time, and the crash time of these activities is specified in days, and the cost is given in rupees. Now for this project we will draw the network diagram. Now you can see we have all the activities from A to H mentioned in this, plus we have the duration of the activities mentioned in the parenthesis. Next we will compute the critical path duration of the project, that is the minimum time taken to complete the project. So we will trace out different paths from the starting node to the end node of the project, and we'll mention the activities that lie on this path and compute the total duration. Now from this we can come to know that the maximum duration is of 30 days and hence the minimum time taken to complete the project is going to be 30 days. Right? So the critical path duration is 30 days and the critical activities are A, B, G and H. Now the critical path is shown by means of the double arrows and all the critical activities are shown in this diagram. Now please understand, if we have to reduce the project completion time, we have to reduce the duration of these critical activities. That is, one of these activities, that is A, B, G or H, has to be crashed if we want to reduce the project completion time. Now please see, we will be computing the cost slope of all the critical activities. Now we have identified the critical activities as A, B, G and H. Now among these activities we have to decide which is the activity that we will be crashing. So for this we find out the cost slope, and which is nothing but the change in cost divided by the change in time. That is, it is the crash cost minus the normal cost divided by normal time minus the crash time. So for each of the activities we compute the cost slope, and for activity A we get it as rupees 2000 per day, for B it is 1000 per day, and for G it is rupees 400 per day, and for H it is rupees 2000 per day. So from this list we have to pick out the least cost slope, right? And which is it? It is for activity G. That is, for activity G we have the lowest cost slope, which means that we will be incurring the lowest amount of additional cost if we crash activity G. So now we go back to our path activity duration chart that we had made, and we see that the critical activities are A, B, G and H, and the project completion time is 30 days, right? Now for the next path the critical duration time is 26 days, right? So we have to reduce the project duration by 2 days, that is from 30 we have to come down to 28, right? And hence it is still going to be larger than the second path. Okay, so let us do the computation now. Okay, now the question says that we have to crash the project duration by 2 days, and hence we will be crashing the activity G by 2 days. Now what is the additional cost that we will be incurring? The additional cost will be 2, that is 2 days, into the cost per day, which we have found out from the cost slope, which is rupees 400 per day, right? So the additional cost incurred will be rupees 800, right? And now the project completion time has reduced from 30 days to 28 days with the additional resources, that is an additional amount of rupees 800. So I hope you have understood the concept of crashing with the help of this simple example. Thank you so much, students, for your attention and time.